To get started, let's simply take a look at the name in front of us, 3-bromo-3-ethylpentane. Before considering any rules, it's important to realize that the name alone can give us a good starting point. First, note the absence of the term cyclo in this name. What does that mean? Well, it means that we will not be drawing a ring structure of any kind, but rather we will be drawing a straight chain molecule. Next, the suffix ane indicates that there is only single bonds present in this molecule. Therefore, we will be drawing a straight chain alkane. Keeping in mind what we've learned about IUPAC and naming of alkanes, I've gone ahead and color-coded our molecule's name with the locant prefix, parent suffix that we follow to do IUPAC naming. So looking at 3-bromo-3-ethylpentane, our locants are in white and they are 3. That tells us that the substituents are located on carbon number 3. What are our substituents? That's where you look at your prefixes, which are in green. So we've got bromine, and we've got an ethyl group. How many carbons are in the parent chain? Pent, that will be 5 carbons in the parent chain. And what is the primary functional group? Ane, we will have all single bonds, so we will be making or drawing an alkane. For the next part of the tutorial, we're going to need our molecule kits if you've got them available. If you don't, go ahead and just follow along the video, but I do think it will be helpful. When we look at the name 3-bromo-3-ethylpentane, it probably seems like a pretty straightforward molecule to draw. With that said, you might think it seems like a little bit of overkill that I'm asking you to model it first. However, I think that because of its straightforward nature, that makes this the perfect opportunity to be hands-on. Modeling is an important tool for success in organic chemistry, and becoming comfortable and efficient building smaller models like these will only make you feel more comfortable later on when the need arises to build more complicated molecules to visualize things like stereochemistry. Here in front of me, I've assembled the pieces I need to build a model for 3-bromo-3-ethylpentane. If you choose to model along with me, please pause at any time and build the same. If you already feel very confident in building models, you can just follow along. But when we look at the name, pent tells us that we're going to need 5 carbons in our parent chain. Ane tells us that we have an alkane and thus only single bonds. I also have a bromine and an ethyl group. Looking back to earlier lessons, even though it's probably second nature by now, we know that the ethyl group is just ethane with 1 hydrogen substituted out, and it'll become a substituent. Our prefixes tell us that bromine and the ethyl group are going to be our substituents. And our locants, which in this case are both 3, tell us that both substituents are going to be located off of carbon number 3 in the parent chain. Because we only have 5 carbons in our parent chain, that will be this center carbon here, regardless of whether you number 1 to 5, right to left, or left to right. So I'm going to go ahead now and attach them. I'm going to leave this on its side just so that you can visualize, but you can see now we have 1, 2, 3, 4, 5 carbons in our parent chain. We have our bromine substituent and our ethyl group substituent, both off of carbon number 3. We'll talk a little bit more later about the associated hydrogens when we discuss condensed structure, but for simplicity's sake and understanding that carbon makes 4 bonds, we can see based on existing bonds where those hydrogens would be filled in. Building this particular model gives us a tangible reference point when we move on to discuss it to drawing our molecule. I've completed another molecule just for visualization's sake with all of the attached hydrogens. I don't expect you to do the same, but if you wish to do so, again, please just pause and complete your own. Your models can now be set aside as we move on to drawing our line structure. We will be drawing 3-bromo, 3-ethylpentane two ways, in line structure and in condensed structure. First, let's draw our line structure. If you've built your model with me or even just followed along with the video, you'll quickly see that we've already done the legwork. We need to remember the same IUPAC rules of locant, prefix, parent, suffix. I've once again color-coded our name to simplify this further. Feel free to take out a paper and pencil and draw along with me for practice, or just follow along the video. It's important that you know where to start. Look first at your red section. Parent. You'll see pent. That tells us that our parent chain will have 5 carbons, which we will draw in now. 1, 2, 3, 4, 5. Looking in blue at our suffix, ane, once again tells us we're drawing an alkane, and thus we're connecting all of our carbons with just single bonds. There you have your 5-carbon parent chain. Next, move on to your prefixes and your locants. You see in green your prefixes of bromo and ethyl, which tell you bromine and ethyl group are our substituents. Locants of 3 tell us that they are located off of carbon number 3, which will be the same carbon here, counting left to right or right to left. Draw them in, and you'll have your completed line structure for 3-bromo, 3-ethylpentane. Remember that model we built? This is where it becomes useful reference. Take a look at your model and you'll see virtually the same thing that we've drawn in line structure. We're going to go ahead and box off our parent chain. 1, 2, 3, 4, 5, and we will see our substituents are both off of carbon number 3. And there you have your line structure for 3-bromo, 3-ethylpentane. Last, let's tackle the condensed structure of 3-bromo, 3-ethylpentane. For reference and to help us complete our drawing, I've included a line structure sketch. In condensed structure, we need to not only include our carbons in our substituents, but our hydrogens as well. To help us, there are 2 important things to remember. First, know that carbon is located at any unlabeled line end or vertex, so we'll go ahead and fill them in now. And don't forget the 2 carbons on your ethyl group. Next, note that each carbon makes 4 bonds. This is what will help us fill in our hydrogens and make our condensed structure very easy. Our first carbon on the very top left only has 1 existing bond. It needs 4 total, therefore we know that there must be 3 hydrogens associated. Our second carbon has 2 existing bonds, so we know 2 hydrogens are associated. Moving up 1, we see that this carbon already has 4 bonds, and thus none associated with hydrogen. Go on here to finish. 2, 3, 2, 3. It is helpful to note here that in condensed structure to write out your ethyl group as CH2, CH3. It is also helpful to make sure to box off your parent chain so not to confuse your parent group and your substituents. Now all we have to do is write out our condensed structure. First, write out the hydrocarbons in your parent chain. Next, add in your substituents off of the correct carbon, which we remember is carbon number 3. And there you have your completed condensed structure of 3-bromo, 3-ethylpentane. If you've made a model set with all of the associated hydrogens, at this time you can compare that to your drawing just to double check the number of associated hydrogens on each carbon. In conclusion, if you're asked to draw structures for 3-bromo, 3-ethylpentane, you have two options. You can draw the line structure, completed in black, or the condensed structure, shown completed in blue. I hope this tutorial was helpful, and good luck on your final exams.